So welcome everyone once again to Bratati Science class. I am Bratati and let's start today's topic. It's great to be back with a new facelift. I hope you are liking this. Like there is an on-screen whiteboard. Previously, if you have seen my videos, I used to write physically on the whiteboard. So it's not that it's obsolete. It will also may come whenever there is some diagrams. And what I'm getting the suggestions actually from my near and dear ones who wants to see that we grow together. Okay, I hope you enjoy my teaching videos. So please motivate me and you can share your feedback and suggestions. If you have do not subscribed till, please subscribe Bratati Science Class and share this link with your near and dear ones and those who are learners, especially of standard 8. And after once we complete all the lessons of 8, we'll move to grade 9 and so on. So if you see my previous videos, you have seen that we have covered all the chapters of grade 7. So once we have completed grade 7, we have moved to grade 8 and then it will be going on so on. Okay, so a quick recap because it was a part one was a trial and error. I mean the trial method. I wanted to see that how this recording is happening and whether everything is going good or not. So though it's a 40 minutes free sessions, I mean let's do this recording and we'll see that in future I have to upgrade myself. Okay, so quick revision that in the last class we have covered the current. What is a current? The conventional current. Then we move to the circuit, the open circuit and the closed circuit. Now, conductor, we were going to talk about the conductors. Okay. So conductors are basically those materials which allows the electricity to pass through it. Okay, so all the materials do not allow, like in the previous sessions, I was showing you the paper, the wood, the plastic, they won't allow the electricity. But if it is a steel spoon, if it is any kind of metal, whether it's iron, zinc, or they will easily passes the electricity through them. So they are called the conductors. In them, there are two types, the good conductors and the bad conductors. So good conductors, any kind of metals and impure water. So there is a magic. Why impure water? Impure water means it's not the distilled water, it's not the pure water. You may have added some salt into it or lemon juice into it. So now it's impure, right? So that can pass the electricity, but not the distilled water or what we call as a pure water. All right. So there are some poor conductors also, like vinegar, acetic acid. Okay. You must have vinegar at home and you can try it, the vinegar and, the normal bulb that needs more water, more currents to glow. But if you do it with the LED, it may glow because LED, as we were talking in the previous session, it takes less current, less electricity is enough to glow, right? So LED is a good tester. We will be learning about tester in today's class. And then there are the insulators. Those materials they do not allow, like plastic, wood, etc. So as we were talking about the testers are the device. Testers are the device that checks that whether this is a conductor or insulator. Got it? Tester is a device which detects that a material can be considered it as conductor or an insulator. Clear? So, when there is a electricity problem, power cut, or any other disruptions, we call the electricians. They come with a tester in them, and you must have noticed that they check it whether the bulb, I mean the light glows in the tester or not. So they check all the points, all the wires that if the light is on, that means electricity is passing through it. So they want to detect the problem, where is the actual problem lies, right? So that is the function of the tester. So let's learn about the tester now. So as I said, the device, this tester can be LED, any buzzer, or magnetic compass. So let me tell you, magnetic compass is the device that with a slight electricity also, the magnetic needle will deflect. Okay, magnetic compass means it's always pointing to the north south, and with the minimum amount of electricity also the needle deflects. So that is the best one. The LED, there is a problem. What can be the problem? The problem is maybe the electricity is more. In that case, the LED may burst or get damaged, right? So the tester should be in such a device that is durable and that can detect even the less amount of electricity passing through it, right? So in this, the first picture, you can see that there is a LED. The tester, the key is closed. When the key is closed, which circuit is this? Open or closed? You're absolutely correct. It is the closed circuit where the key is closed, and we can see there the cell is there that is having the plus and the minus, and this tester will show that whether this light glows or not. So in case the light glows, in case the light glows, why it's coming red only? Uh, I don't know. Okay, so this bulb will glow. That shows that the tester shows that whatever material is there in the circuit, that is a good conductor or a poor conductor, but it's a conductor. So there will be actually the metal or the material what we are talking about. Okay, so this, it can be metal or it can be any other material, like it can be a plastic, a wood, or our material. So this tester is basically this one. Okay, so now looking at the compass, the magnetic compass in the second picture, where it has the two needles. So with the slide, this tester can be, yeah, this tester can be any metal or it can be plastic. Okay, and this is how we can test actually whether it's passing the electricity or not. So tester concept is clear, I hope. Tester is the device which shows or detects that whether a material is a conductor or an insulator. If it is a conductor, that means with that tester, the LED or the magnetic compass will show the change in them. If it is LED, it will start glowing. That means the circuit is complete and it is the metal or the material which is used as a tester, it's passing the electricity. But if it is plastic, wood, paper, or any other materials, that means the tester will detect the light will not glow. The LED will not glow, or the magnetic compass, the needle of the compass will not deflect. As it's not deflecting, that means electricity is not passing through this material, which shows that it's an insulator or it's a poor conductor. Clear till this? So now we are moving to that electricity also passes through, solids or liquids. Okay, so our next is, we are moving to the that electricity passes through liquids. We will be talking about solids, as these wires and all we are talking about, it's solids only, right? So these wires and this circuit is made up of in the solid substances, like we have cell, we have key, we have a tester, with that can be metal, plastic. So this is solid. So we are talking about solid. We will also talk about solids in the forms of fruits and vegetables, that is coming in the next slide. So before that, liquids also conduct the electricity. Now, if it is pure water means there are no free ions. Okay. So here, what are the free ions? Basically, the ions can be positive or negative, cations and anions. The positive are the cations, the negative are the anions. So when there are plus and minus ions present in the liquid, then the electricity can pass through it. Basically, the ions are only passing the electricity. As we know, the current or electricity is the flow of electron. So if the negative charge is there in the liquid, then the electricity will pass through it. But if it is like a compound, whether there are no free ions in it, then electricity cannot pass through it, right? So here we will be seeing this one, like where it's a tap water, salt water. When it is tap water, there are a lot of impurities in it, right? It's not the pure water or distilled water. And now in the pure or distilled water, when you are adding salt, NaCl, sodium chloride, okay, or you are just squeezing the lemon, you are making it a lime soda, or you can make it lime water, lemon water. So even then, it is impure water. Those are the good conductors of current or electricity. But if it is the pure water, or you are adding sugar, okay, when you are adding sugar, that means you are adding sucrose, and sucrose is, you know, that a type of variations of the glucose only, which will not deviate into the ions, okay, it will be like a compound. That's why with the pure water or the sugar solutions, the current or electricity won't pass. But now see, in the first picture, we can see there we have put in this liquid, if it is the water also, we have added acid to it. So once we have added the acid to it, there are only these options. Okay, let me take this one. So then the bulb will glow. You can see the LED is glowing. The LED is glowing because that acid is helping the electricity to pass through this circuit. Okay. So first case, yes, the bulb glows. The second case, base. Now what is base? It is the soap, liquid soap. Everybody we have, even the surf excel. Okay. The washing machine powder. Okay, that means washing powder, or it can be liquid soap. They are the base. Basically, they are sodium caustic soda or caustic potash. That means the sodium hydroxide or the potassium hydroxide. They act as a base, and even then the light will glow. The bulb will glow. That means base also can pass the electricity. Now we are third picture. In the third picture, we are putting the salt. It is the table salt. The normal table salt is sodium chloride, NaCl. So when we are putting the salt, it is dissolving into this water liquid, and it is, you know, ionized to Na plus Cl minus. So again the ions are generated. So this salt also will pass the electricity. The bulb will glow. So in this case also it's correct. Now if we take this color, so acid means we can take, you know, citric acid or any other like acetic acid. Acetic acid is like CH3 plus and COOH minus. Similarly, if the base is like we were talking about Na plus and OH minus, and in the salt we can say Na plus and Cl minus. So these are all basically the ions. So when it's ionized, it's the electricity can pass through it. Clear? Shall we move? Okay. The next is, as we were talking about the solid, one more is through potato, like this one. Okay, in this you can see the electricity passes through the potato. Potato is nothing but any vegetable. You can take any other vegetable or fruits, and you can check that if we are connecting, making it a circuit, so whether the electricity is passing through it. So you can do it at home. You just need a tester, like here LED bulb is there. You need the cell. So as you can see, there are cell, like we have, it has the positive end and the negative end, right? So this is the potato. The potato, when you are completing the circuit with putting the two electrode in it, okay, two electrode, the tester, the key is there and the cell is there. So the circuit is completed. You have to wait for some time. Like you are doing the experiment and then you are moving around for some time, and when you come back, there is a magic waiting for you. Do you know what is the magic? The magic is nothing but there is a green patch present at the positive end of the potato. It's only present which part or which electrode is connected to the positive side. Okay, the positive side anode and the negative side cathode, that we will learn about for the electrode. So here from this experiment we also come to know that in my cell which is the positive side and which is the negative side. So what can we see here? The color of the potato is you know, that slightly yellowish, or what can we say, that is wheatish color. But when there is an electricity, after some time, not immediately, some solution, some chemical is being stored here, and that's why the color changes in the potato. Actually in the potato, it's the phosphoric acid H3PO4 is present. So H plus, it's plus, and PO4 minus is present. So again, it is ionized. So as we know, if it is ionized, so let me write this is phosphoric acid, and this is present in potato, and that is why, okay, that's why it is showing the change in color, because the electricity is passing and reacting to this H plus and PO4 minus, this phosphate ion, and that is the reason this greenish color is being coming. And in this, you can see the bulb is also grown. So if I can show you this one, this bulb glows. Coming here. Okay. So the bulb glows. Okay. So now, how can you see and how can you understand that there are some chemical effects going on? There are some chemical reactions going on. So if any chemical reactions is going on and electricity is passing through it, we can see few changes. That is, the first is the change in the color. Okay, we can see the evolution of the bubbles will be evolved. And third one is the depositions of the metals. Like, what is that depositions of the metals? This is something called plating or coating. That is our next topic. So depositions of metal means on any one metal, if we want to coat it with another metal, okay, then we have to put whatever we want to be coated, that to the it will go to the plus. I mean, it will be in the cathode. And what we want to be coated, that will come to the anode. Okay, so that is our next topic. Let's see what we call it. We call it by electroplating. Now, plating is simple, nothing but coating, as we were talking about. Coating of a metal on another metal with the help of electricity, right? So this is called electroplating. So here, when we will be discussing about electroplating, we will come through the term called electrodes. What are the electrodes? Electrodes are the solid conductor that carry the electric current or the electricity through non-metallic solids. Okay, it can be non-metallic solids, but we can deposit the metal on it. Okay, in electrodes there are two kinds, rather, positive and the negative. The positive, that is the anode, and the negative is the cathode. The positive, the anode, shows the oxidation. Now, what is oxidation and what is reductions, we will be learning later on. So as of now, I will show you what exactly is going on there. So this is the picture of electroplating with the positive and the negative electrode, that is cathode and anode. Now see the battery, the cell. So in my cell, the positive and negative end. Here, the negative end is attached with the cathode, and this will be anode. Okay, so here what we have taken the liquid in a beaker and we have put the two electrode. Now here, to be mentioned, this both the electrons are made up of copper. We can brush it and we can wash it thoroughly, and then we can use this two copper electrode, and where we are suspending to the copper sulfate solution, blue vitriol, that is the greenish blue in color. So we are dissolving them or putting them, suspending them into the copper sulfate solution. Then we are completing the circuit with our usual cell keys and the detector, like you can have the LED bulb or the magnetic compass, like the tester. So here what will happen, immediately you cannot see any changes. But after some time, as I said, you need to give some time to it. You can see the negative part, cathode, that copper, there is some changes. There are some deposition on it. Okay, there are something called coating. Now what can be coated? Now, as we know, it is the solutions of copper sulfate. So the copper will break down to the ions like Cu2 plus and SO4 2 minus. Again, they are the cations and anions, positive ions and the negative ions. So when the ions freely moving in the liquid, then the copper part, which is the positive for the cations, will move to the cathode, right? The cations, these are the cations here, Cu2 plus, they will move to the cathode. The anions, which are the negative one, the anions will move to the anode. Okay, so remember, cation to cathode and anion to anode. Cation, the positive charge, that will move to the cathode. The cathode is connected to the negative end of cell, and the anion, which is actually negative charge, and that will go to anode, which is connected to the positive end of cell. Is it helpful? In this way, you can remember that cation positive will move to the cathode, which is attached to the negative end of the cell, and anion, which is negative, that will move to the anode, not this color. We can take any other color. So, oh, it's not working actually. Okay, like this, you can remember this is the tips. If you remember this, there will be no confusion. Anode to anion, cathode, anion to anode, cation to cathode. Okay, easy? Thumbs up. Okay, so let's move ahead. Same, that setup we can do with the zinc sulfate solution. So here we want to coat any other metal with a zinc coating. Okay, so generally the zinc is being coated to iron, steel, and to prevent the corrosion, or we call it rusting. Okay, so do you have any idea what is rusting? I hope you know this. Share. Stop share. Okay. So what is rusting? Basically the iron or the steel, they get brownish color on them. That is because the iron is very much reactive, highly reactive in the open air when it's getting in touch with the moisture, with the oxygen, and they develop ferric oxide on it. Okay, so ferrous is for iron, and they get it is the reactions with the oxygen and the moisture, so they brought ferric oxide, which is called rust. And when the sheeps and many, the factories and buildings, and there are a lot of steels used, right, in vehicles, all kind of vehicles, if they are rusted, then it will be damaged after some time. Even the big gates, school gates, or any other, okay, like in a port, right? So we have used a lot of steel items, so we need to protect them. So in order to protect them, we need to cover or coating them. For coating, this process where we are coating them with the zinc, it is called galvanization. Okay, galvanization. That is the zinc coating on any other metal, especially the iron or the steel, to protect the iron from getting rusted. Clear? So let's see the setup. This is the setup for galvanizations where we have the anode and cathode. So we can take cathode as whatever metal, like it can be a steel key, or it can be a steel spoon, whatever you want to be coated with the zinc. So we will take an anode, we will take a cathode. In the cathode, yeah, in the cathode we can take the iron or the steel, and the solutions where we are suspending them to the zinc sulfate solution. Again, zinc sulfate will be ionized to Zn2 plus, I mean Zn class plus, and SO4 minus. So here, can you tell me what is the anion and what is the cation? So here Zn2 plus, this is the cation, and that will go to the cathode part, and SO4 minus, this is actually the anion, right? So this is the anion. So this is cation and this is anion. So these are the ions, the free ions, and these free ions will be present in the liquid, the solution. So here you can see this was the key, and there was a coating of the zinc, which is protecting the key for future to get rusted. All right, and the sulfate solutions will come into the anode part. So cation will go to cathode, anion will go to anode. Now, what is the use of galvanizations? We already discussed. What is the use of electroplating? The electroplating is mostly used for, that gold ornamentations. What is that? Gold plating. So we know that as women, we have any other metal, can be any other jewelry, like which is not originally gold, but they're gold plated. Okay, gold plated means it can be a cheaper metal on which we are putting a coating of gold, because solid gold, it's very costly, day by day the price is being increased. So we may have the gold plated organ, jewelry. Second thing, you must have seen the taps of basins or the spoons and all. They are very shiny. Okay, so how to bring that shiny ness on the metal? So it is due to the chromium. So chromium is again a very costly metal which we cannot use completely, but we can give a chromium coating on these metals, right, which will appear shiny. So chromium for shiny appearance, gold for ornaments, then zinc to prevent the rust. It also, the cars and vehicles, you must have heard about anti-rusting coating and the film and all that too, because those are going in the rain, the air and sun and all, to reduce scratching and also the durability of the metals. So these are the use of the electroplating, right? So what is basically happening here? Oxidation and reduction means here, the positive ion that is coming out. So oxidation. So that's what we were talking about here. You remember that positive, the anode, there the oxidation is going on. So here the anode part where the oxidation is going on, and the oxidations means, the release of the, no, actually cathode is attached to the negative part. So one is actually releasing the electrons and other one is accepting. So definitely the cathode will be releasing the electrons, the negative charge, and the anode will be accepting. So positive to negative. So again, you are matching the conventional current that according to the Brain Franklin, he said that the current moves from the positive end to the negative end, because from positive end we are giving the electron to the negative end. So anode is releasing the electron, and that is the reason we call them oxidation. Whether the cathode is actually accepting the electrons, that means getting the negative charge, so we can call them as reductions. I hope you have understood this one. Okay, so we are to the end. So I hope today's class you have enjoyed, and I'm tried my best to make you understand with this new method. So please be with me. Thank you so much who have already liked and subscribed. And yeah, see you in the next video very soon. So stay tuned. Take care. All right. Share your learning. See you in the next video. Bye.